StatQuest, Naive Bayes, StatQuest, Gaussian, StatQuest. Hello, and welcome to StatQuest live stream. One day I'm going to get this introduction just right, but not today. Thanks for joining me. We've got people coming from all over the world. Lots from India. India's great. We've got Nepal, Germany, Argentina, Brazil, Peru. Holy smokes. I don't know if I've ever had South America covered so well. Germany, Sweden, France, Indonesia. I don't know what time it is in Indonesia. It's got to be like someone is up late at night there. Anyways, I'm really excited you guys are all here. This is going to be a lot of fun. And today we're going to talk about Naive Bayes Gaussian. All right, so let's get started. Imagine we want to predict if someone would love the movie Troll 2 or not. So we collected data from people that love Troll 2 and from people that do not love Troll 2. We measured the amount of popcorn people ate each day, how much soda pop they drank, and how much candy they ate. The mean for popcorn for the people who love Troll 2 is 24, and the standard deviation is 4. And a Gaussian distribution with mean equal to 24 and standard deviation equal to 4 looks like this. Likewise, the mean for people who do not love Troll 2 is 4, and the standard deviation is 2. And that corresponds to this Gaussian distribution. Now we calculate the mean and standard deviation for soda pop for people that love Troll 2 and draw the corresponding Gaussian distribution. And then, likewise, we do the same thing for people that do not love Troll 2. Lastly, we draw the Gaussian distributions for candy. Okay, here's a pop quiz. Can anyone guess why this version of Naive Bayes is called Gaussian Naive Bayes? I'm not going to give you a hint. Yes, you are correct, or at least I hope you are. If you're not, Anyways, let's assume you're correct. It is because we use Gaussian distributions to represent the data in the training data set. Okay, now remember, the x-axis on this graph represents how much popcorn someone eats in a day. So we see that people that love Troll 2 tend to eat more popcorn than people that do not love Troll 2. And by the way, I love popcorn. I could eat that thing all day. Okay, likewise, people that love Troll 2 tend to drink more soda pop than people that do not love Troll 2. This might be because popcorn is usually salty and pairs well with refreshing soda pop. So, if someone new comes in and says they eat 20 grams of popcorn each day, and they drink 500 milliliters of soda pop each day, which by the way is a lot more soda pop than I drink. I rarely drink soda pop. And they eat 25 grams of candy every day. I don't eat a lot of candy either, but I do eat a lot of popcorn. Then we can use Gaussian Naive Bayes to decide if they love Troll 2 or not. The first thing we do is make an initial guess that they love Troll 2. This guess can be any probability that we want, but a common guess is estimated from the training data. For example, since 8 of the 16 people loved Troll 2, the initial guess will be 0.5. So we put that up here so we don't forget. Likewise, the initial guess for does not love troll 2 is 0.5. So let's put that here so we don't forget. Now, the score for loves troll 2 is the initial guess that the person loves troll 2 times the likelihood that they eat 10 grams of popcorn given that they love troll 2. And right now we're just assuming that they love troll 2. We don't actually know yet. We're just assuming that if they loved troll 2, we're going to calculate the likelihood that they will eat 10 grams of popcorn. And note, the likelihood is the y-axis coordinate on the curve that corresponds to the x-axis coordinate. So you can see we start on the x-axis at 10 grams, and we go up to the curve, and bam, that's where we intersect the curve, and we just figure out what the y-axis coordinate that corresponds to. That's the likelihood. And if this is kind of confusing, or you saying, hey, why isn't that a probability? There is a StatQuest. This is a blatant self-promotion right here. There is a StatQuest that explains the difference between likelihood and probability. So check that one out. It's subtle but useful in times like these when you need to know what a likelihood is. All right, continuing our multiplication, we include the likelihood that they drink 500 milliliters of soda pop times the likelihood that they eat 24 grams of candy. So let's plug in the numbers. 0.5 for our initial guess. And for popcorn, we've got a pretty small number. And for soda pop, we've got a slightly larger number. And for candy, we've got a really, really small number. Note, when we get really, really small numbers, it's a good idea to take the log of everything to prevent underflow. So, we take the log, and note, any log will do, but the natural log is the most commonly used one in statistics and machine learning. So that's the one I use all the time. I rarely, if ever, think of the other logs unless there's an earthquake or I'm at a rock concert and I'm wondering how loud the sound system is. Okay, when we use the log function, we get a sum because the log turns multiplication into addition. And the sum is equal to negative 129.7. Bam! Okay, I went too fast. That's our score for the log of the loves troll 2. Or that's the loves troll 2 score log. Bam. Okay, now let's calculate the score for not loving troll 2. We'll start with the initial guess that someone does not love troll 2 times the likelihood that they eat 10 grams of popcorn given that they do not love troll 2 times the likelihood that they drink 500 milliliters of soda pop times the likelihood that they eat 25 grams of candy. So let's plug in the numbers. Boop, 0.5. Boop, boop, boop. And use the log function to convert the multiplication into a sum. And we get negative 20.16. And since negative 20.16 is greater than negative 129.7, we classify the person as someone who does not love troll 2. Double bam. So, if you... I kind of went fast through Gaussian Naive Bayes because we talked about normal Naive Bayes last, what is it called? Live stream. And we're actually going to do a quick review in just a little bit because I'm going to talk about why Naive Bayes is naive. But I think you guys get the general idea. We just, for each, hold on. For each thing in our data set, we calculate a Gaussian curve. Bam. bam, 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 bam. We calculate these Gaussian curves and we use them to calculate likelihoods given that they either love troll 2 or they don't love troll, and we basically just multiply those likelihoods together. It's not rocket science. All right, so now let's move on to some fun stuff. We're going to talk about why naive Bayes is naive. However, it's easier to explain this concept using the normal messages versus spam example that we used in the last live stream. So let's do a little review. Last time we talked about naive Bayes. We walked through an example where we had normal messages from friends and family and spam, unwanted messages that are usually scams or unsolicited advertisements. And we used naive Bayes to filter messages for us. We made histograms, and we calculated the probabilities that we would see each word in normal messages and the probabilities we would see each word given that it was in spam. Then we calculated the initial guess that a message was normal based on the number of normal messages and spam in the training data set. And then we calculated the initial guess that a message was spam. Then we used all of those probabilities to classify this message, dear friend. Hi, friends. Okay, to start, we multiplied the initial guess that the message was normal by the probability that we would see the word dear in a normal message and the probability we would see the word friend in a normal message. And after plugging in the numbers, we got 0.09. The score for the message being normal, given that it says dear friend, is 0.09. Then we multiplied the initial guess that the message was spam by the probability we would see the word dear in spam and the probability we would see the word friend in spam. And after plugging in the numbers, we got 0.01. So the score for the message being spam, given that it says dear friend, is 0.01. And since 0.09 is greater than 0.01, we decided that dear friend was a normal message. Bam. Okay, now that we're done with the review, let's talk about why naive Bayes is naive. Imagine we got a bunch of normal messages. And this is what each one said. Just like before, we can make a histogram of the words and calculate the probability we will see the word dear, given that it was a normal message, and the probability we see the word friend, given that it was in a normal message. Now we can calculate the probability of seeing dear friend. We start with the probability we see dear times the probability we see friend. Plugging in the numbers gives us 0.25. However, this value, 0.25, ignores the fact that in the original messages, dear and friend were found together a lot of the time. In other words, if you tell me that the first word is dear, then that means the message is most similar to these 4 messages in the training data set. And that means the probability of seeing friend should depend on having already seen the word dear. In other words, if I know the first word is dear, these 2 messages should not affect the probability of seeing the next word. So the probability we see the word dear is the same as before, since 4 of the 9 messages started with dear. But once we know the first word is dear, and 3 of the 4 dears are followed by friend, the probability of seeing a friend, given that it was preceding with dear, in a normal message is 3 divided by 4. And doing the math gives us 0.33. And this result is different from when we ignored the relationship between words in the training data set. Ignoring the relationships between words in the training data set is what makes naive Bayes naive. Bam! Now, you may be wondering why naive Bayes ignores relationships between words. This training set is super simple because I just needed to demonstrate how naive Bayes works. However, in practice, a real training data set might have thousands, if not millions, of examples of normal messages. And in a large training data set, we'll get longer messages, where there are lots of phrases and word combinations that are commonly used together. So in here we've got, how are you? That's a real common phrase in the English language. To say I'm well is a very common thing to say. So those words are commonly found together. Last night I ate pizza. A lot of people in English-speaking countries or people that speak English eat pizza. So you might see the phrase last night I ate pizza a lot. Some people eat pizza and salad, but some people just eat pizza. Anyways, accurately modeling every single phrase in a language would be impossible. So naive Bayes doesn't even try. However, like we mentioned last time, naive Bayes tends to work well in practice. In other words, by ignoring relationships among words, naive Bayes has high bias. But because it works well in practice, naive Bayes has low variance. And if you don't know the difference between bias and variance in machine learning, well, here's another blatant self-promotion. Check out the StatQuest. Triple bam. Actually, no, I blew it. My own joke. Triple spam. Oh, I guess it's a live stream, so I can't go back and do it again. Oh well. Here's we've gotten to the end of sort of the prepared content. I'm gonna go over to the comments and see if we got any good comments, or see if we got any what are those super chats or something like that. I want to do some shout outs. Let's see what we got over here. Oh, I also want to say I hope you guys are all doing well and are healthy. And if you're not, you're getting the care you need. I know these are tough times. I thank you for visiting me during my live stream. I know there's a lot going on and you might be worried about family and friends. So it means a lot to me that you're joining me today. And I hope you're doing okay. Let's see what else we got. Oh, Italy, Honduras, Denmark, Romania, Israel, Portugal, New York City, Korea. Some people are up really late at night, it looks like. Vietnam, holy smokes. Bangladesh. A lot of people ask if I'm going to post this afterwards. I post all of my live streams. If they're not easy to find, I don't know if they're on the StatQuest YouTube page, but I always put them on the statquest.org video index. It takes me a few hours to get them up. I edit the live stream records the first like 10 minutes where all it is that sort of that screen where it just says, hey, StatQuest is about to start. It records all that, and I have to edit that off, and I can trim that off. But for some reason, it takes hours to do. I don't know why. It's a total mystery. But it takes hours to do. So the live stream will be posted probably around 4 o'clock p.m. my time. I don't live in New York, but I know a lot of people know where New York is. So I say it's New York time. Actually, so there's that. What else we got? We got some channel members that are talking, which is nice. It's always great to see channel members. Channel memberships are really important right now. I think with the global economy, everyone is hurting. And that's not good. Uh, and if you're hurting, or you've lost a job, or your parents lost a job, or something like that, I my heart goes out to you, and do not feel obligated to support me. But because the whole economy is tanking right now, ad revenue from YouTube is also tanking. So my revenue has got dropped by 25% in the last couple of weeks. So that's a little bit scary, but we'll see. I'm about to come out with, I guess I'm just rambling, but I just want to let you guys know that I'm about to come out with some PDF study guides. I know a ton of people ask me if they can have the PowerPoint slides or the slides from my StatQuests, and the answer to that is no, because that's my livelihood. But what I'm doing is I'm making these PDF study guides, which are um, uh, just like 6 pages of just it's like everything you need to know in 6 pages. They kind of assume that you've seen the StatQuest, um, because it doesn't walk you through everything in very small steps, but it's got all the main ideas there, and they're beautiful. They look beautiful. Um, and I'm making these, and I'm going to make those for sale for real cheap. And that's going to be another way that you can help support the channel, is by purchasing the StatQuest study guides for the subject of your choice. So actually, that's something you guys might want to comment about. If there's something you would particularly like to see a study guide made for, let me know. That's something I'm going to try to dedicate a couple hours each day to making a new study guide. It actually, making a study guide actually takes, because everything I do takes forever. Making a study guide actually takes a couple of days because I want it to look good. Um, and it's also interesting. It's a different problem for making a stat quest. It's a sort of a different puzzle to solve, and so I end up having to think about it. Like, what's the best way to present the information in this smaller format, where I can't walk you through things every little step? Is there a way I can still convey just as much information? So I end up like scratching my head a lot, going, "How am I going to do this? How am I going to make it right?" So they take a little while, but if there's something you guys want a study guide on, put it in a comment or post it later on the as a comment to the live stream, or some other video. That's something I'm doing. Um, okay. Oh, here's another thing I'm working on, and I'm also working on Jupyter notebooks of how to do machine learning in Python, and it's from start to finish. So it includes downloading the data, it includes massaging the data, dealing with missing data, dealing with when you import it, it's got the wrong data types, dealing with all those kind of finicky issues. Okay, but then we make the machine learning we make the machine learning model, and then we optimize it. We do cross validation, we do grid search, we do all these things, and then we draw a picture to visualize what we did. And so I've got 4 of those that I've made already. I'm just sort of like trying to figure out a way to put them online. That might be just something I give to members and Patreon supporters. But they're pretty cool. Jupyter notebooks that just go through everything, and I've spent a ton of time on those. So that's a real exciting thing that we're working on. Uh, Someone asked where they can buy these study guides. I'm hoping in the next week I will have an announcement of where you can do that. I've got 2.5 study guides made. I'm going to make 2.5 more, and then we're going to upload them, and then we'll have a little store, and I'll send out a link. There'll be a link from uh, I'll send out an announcement on YouTube, but there'll be a link on my store. On the statquest.org, and I'll be promoting that. So those will be fun to get. Oh, logistic regression. Somebody wants that. Yes, I'm doing logistic regression. Someone wants neural networks. I see lots of people want neural networks, and yes, that one's coming. However, I want to do the StatQuest first, and I've started working on it, but it's always like a month away. It's so frustrating because something always comes up. But I have started working on neural networks. And so that one is coming. Um, Someone wants to know how to get started with machine learning after learning all these things and a few algorithms. Is that like as a career? Is that like with just started, like you've learned the things in abstract and you just want to practice? If you just want to practice, my Jupyter notebooks, which will be out soon, would be a perfect place to start because it covers every little detail of how to get it going. Um, Someone else wants structural equation modeling, which sounds crazy fancy. Um, um, what else we got? Bayesian linear regression. Uh, yeah, that's Bayesian stuff. Uh, is it's on the to do list. Someone else wants general linear models. Yes, we're working on that one for sure. That'll be one of the first. That'll be one of the first 5 that come out in the next week. Because that is something that's near and dear to my heart. Um, yeah, someone asked if the Jupyter notebooks could be for purchase for non-members too. Yeah, I'll look into that. That sounds great, and it sounds like uh, um, sounds like Mohit wants to know as a career. Um, by the way, before we get to that, I would want to do a shout out to Vadim Ivanovsky. They just signed up for early access. They became a member. That's awesome. That's great. Um, yeah. So how to get started on a machine learning career? Um, Other than just apply for jobs, internships, practice a lot. Uh, I don't know. Yeah, it's a little embarrassing. Um, However, to that end, one thing that I've requested before and I will request again now is some people in the comments will ask, could you address common interview questions? And I would be happy to do that. Since I'm not interviewing for these jobs, I don't know the questions off the top of my head. So if you can post questions in the comments, on the chat, um, through the contact me pay on the statquest.org website, that would be a great place to send me some questions, and I would be happy to do a live stream where we just go through these questions and kind of knock them out. Um, uh, the difference between AI and data science. Um, that's an interesting question. Um, AI, I think specifically, I mean, it used to be, back in the 60s, AI was specifically like trying to find, programs that could beat everyone in chess. And they were genuinely trying to come up with something that could learn on its own and simulated real intelligence. Whereas machine learning, we know about machine learning. Machine learning is sort of just like fancy statistical methods. Um, but the machine learning thing will never sort of like, you know, become self-aware and take over the world. Whereas I think back in the early days, artificial intelligence really was trying to come up with algorithms that could teach themselves new tricks. And I think over time, since the 60s, they've moved into more machine learning areas, and that's fine. And so the question to me now is, what's the difference between machine learning and data science? And machine learning um, is a part of data science, but data science I think is a little bigger than that. Data science, in my mind, involves like database work, which is useful in machine learning because a lot of your data comes from database. But I think if you're a specialist in machine learning, you're going to know more about the algorithms, know about more about how to train them. You're going to know more about how to apply them, deploy them, blah blah blah, all that stuff. Whereas if you're more data science, and don't quote me on this, or maybe quote me on this and just say, well, that's what Josh Starmer of StatQuest said, but what does he know? I think with data science, it's more general, like data analysis, as well as like knowing some machine learning things, but it's also knowing how to come up with awesome looking graphs, how to summarize complicated data sets where you've got thousands of variables. How do you condense that to easy to interpret UMAP graph or a T-SNE graph or a PCA plot. And, so that's what I kind of think. That's what's going on. Um, oh, so some people just asked if I could explain the membership thing for my channel. So I've got memberships, channel memberships. I don't know if there should be maybe somewhere on your screen it says become a member. That's you can do that through YouTube. I also have a Patreon thing where you can become a Patreon through and support me through that. Different people have it's through YouTube it's a little easier to do it through Patreon. Patreon sort of compensates for making it a little harder by making sure a larger percentage of the money you give that comes to me. But either way is fine. I love the support either way. But what it is if you become a member, you can become at different levels. If for $1 a month, you get early access, which means you get whatever the new StatQuest is, one usually about 2 weeks in advance, 1 to 2 weeks, maybe 1.5 weeks on average. 2 weeks in advance, 1 week. Anyways, if you give a little bit more, you get discounts on merch, which isn't a huge deal. Although I am wearing my StatQuest T-shirt, I love it. You get 10% off merch, and I think you'll get 10% off the study guides. Uh, if you give a little bit more, you get your name on the StatQuest website every time I post a new video. And if you post and you contribute even more, and I don't expect a lot of people to be able to contribute at that. We're talking at this level, we're talking $20 a month. I put your name at the end of the StatQuest video, and for a crazy amount of money, $50. No, it's $42 a month. You get an album of silly songs plus all the other stuff. So that's sort of the idea behind memberships. I'm trying to do special things for those people, but to be honest, I know not everyone can support me, so I try to do special things for everybody. But yeah, they all get early access, and some of them get their name recognized because it's very supportive for me. Oh, someone asked, how do I decide to use R or Python in my data analysis? And I say it depends on the data and sort of what type of analysis. So when I was making my Python Jupyter notebooks on machine learning, I wanted to do one on. I did neural networks. I did decision trees. I did support vector machines, and I did one more. Hold on, let me check. What did I do? XGBoost, and I did XGBoost, which is awesome. Oh, holy smokes! We got another early access member, Mark T. Thank you for joining. Anyway, so I did those, but I wanted to do random forest. However, the implementation of random forest in Python is terrible. It's way better in R, and I don't know why. There's no real reason for it, but in R, random forest have some really cool features for imputing missing data and visualizing crazy complicated data sets, which I like and I kind of love. And for some reason, you can only do that in R. You can't do that in Python unless you code it yourself. So in that case, if I want to do a random forest, I'm doing it in R, hands down. However, other than that, it sort of depends on what kind of environment I'm working with, who I'm working with. XGBoost, for example, it has kind of the same interface for Python as R, so it's sort of like wherever you are. If you're already doing Python, then just stay in Python. If you're doing R, just stay in R. Um, if the data analysis, if it's less machine learning and more just data analysis, I'll do it in R, because R, you don't have to import you don't have to import NumPy and pandas and stuff like that. You don't have to have like np dot normal distribution or whatever. You can just type give me a normal distribution in R. It's super easy. However, Python is great in that it's got flexibility to do anything. If I want to deploy like my machine learning thing in a production environment, I'm going to find a lot more ways to do that with Python. So Obviously, it always depends. Um, so yeah, I mean, both languages have pros and cons. Both languages have tons of support on Stack Exchange and Stack Overflow. So and that's how I code. I'm like, I wonder how they do it on the web, and I Google it. Anyways, thank you guys very, very much for joining me for today's live stream. I hate to end it. I always have to end it, and it always surprises me when we get to the end of the live stream. Um, Let me know in the comments what you thought about this time of day. I'm still just trying to figure out what the best time of day is for a StatQuest. Um, and I still think it's going to be 2 times of day. Like I'll do a morning one for me. It'll be 9 a.m. and that allows me to get Japan and some of China and places like that. Um, and maybe a noon one, and that hopefully will get the rest of the world. I don't know. So that's another thing we're kind of working on, and I'm just sort of looking at the statistics and the feedback that YouTube's giving me, so I can see whatever gets the most people available is great. Oh, and before we go, I want to give a bam out to Josh Erickson for joining, becoming a member. That's great. Thank you very much. All right. I know I keep saying we're going to leave, and I keep saying there's one more thing to say. The next time we're going to do conditional probability and basic probability. That's going to be the next live stream. So get ready for some basic probability and understanding conditional probabilities. All right. Until next time, quest on.